okay? So I literally have a bell, and if you think you know the answer, you're going to come up and ring it, okay? And if you're correct, then you can have a Jolly Rancher to start off class. So I'm going to put it on the screen in a second. When you think you know the answer, come up and press the bell, and then we'll check to see if you're right. They'll show up in a second. Yeah. What do you think? Nope. Sit down. 300, perfect. If you want Jolly Rancher, you can go grab one, Crocker. All right, so we'll just do something. It'll just be a little math puzzle at the beginning. So that is the one today. When we, here, not when we, the first section, we're taking 2 sections of notes today, so today might seem a little long for notes, but that's just because we got to get the basics down. So if you want to write down at the top, understanding points, lines, and planes, that is what our first section is going to be about. All right, and just a heads up on that, the first part, it's going to kind of look more, you're going to have more little definitions, but that's not going to be a lot of this class. It's just going to be kind of the beginning part. Okay, so just a little warm up. Or not, we won't do that. Never mind. So what we're talking about, okay, points, lines, planes, okay? Here's going to be those definitions, okay? It's going to be those terms for a point, a line, and plane. It's important to know how to name those points, those lines, and those planes, and then also what that's going to look like. Okay, so when you're writing, a point names a location and has no size. It is represented by a dot. Okay, all it is a dot, and when you label it, it's that dot with the letter beside it. All right. Then we get to a line. Okay, the line is a straight path that has no thickness and extends forever. All right. So we will focus on naming the lines with this XY or YX. Okay, it can be named either or, but it's important to know that line extends forever. So when you write XY, or if you write YX, you got to put that line above it, and it has to have the arrows. Okay, because eventually we're going to show a different way that looks very similar, but it's not going to be a line. And we'll talk about that in a second. Then finally, for a plane, okay, a plane is a flat surface. Okay, it has no thickness and extends forever. As you can see in that diagram, okay, it has the letters A, B, and C in it. We'll be focusing on planes with A, B, and C rather than the R. But just know that we'll name it, it has to be 3 points not on the line of the plane, but just 3 points inside of the plane. So there might be more than just 3 points. When you name that plane, okay, you just have to have at least 3 of those points inside the plane. Not on the line, inside. When you're done with those notes, just go ahead and put your pencil down so I know who's done. And then I will move on to the next part. All right, on the next couple slides, if you just need to abbreviate, you don't have to write it word for word, just so I can kind of move on and we're not taking notes the whole 80 minutes today, okay? I'll also attach these notes. I'll put them in Google Classroom as well, so if you need to catch up on a couple of those, you may do that. So when we talk about a line, okay, there's ways that, depending on the points, if they're on the line or not, okay, we'll name them either collinear or coplanar. So, like it says, the points that lie on the same line, they're going to be collinear. So if you look at this line right here, okay, we have the letters K, L, M, and N. Well, since K, L, and M are on the line, those are going to be collinear. And then points that lie on the same plane, they're going to be coplanar. Okay? You can kind of just ignore the parts about, you don't need to write the K, L, N are non-collinear or the otherwise they are non-coplanar. Just know what collinear and coplanar are. Okay? So the collinear is if those points lie on the same line, coplanar, the points that lie on the same plane. Okay? And that. All right. I know this is going to be a lot, okay, but just abbreviate if you need to, okay? So for our next part, okay, we have segment, endpoint, ray, and opposite rays, okay? When I was talking about earlier about lines, okay, it's kind of that opposite is a segment. So when we talk about a segment, or if I say line segment, I'm talking about the same thing, okay? That's the part of the line consisting of 2 points and all the points between them, okay? But with the segment, it has 2 end points. So if you look at that diagram, okay, it has A and B, and as you can tell, the line stops there, okay? The line doesn't keep going, okay? There's no arrows at the end of those, because if it kept going, then that would be a line. But since there's no arrows, then this is a line segment, okay? So we're going to be working with these today and kind of doing some numeric line segments, some algebraic non-line segments, and we'll go more into segments today. But just know when you label those, okay, again, it can be AB or it can be BA, okay, but when you're putting that so you know the difference between a line segment and a line, you're just putting a line with no arrows above those letters, okay? All right, and then at the end of those segments, okay, where the line stops, okay, those are end points, okay, so that is just the point at one end of a segment or the starting point of an array. And yeah, you can just label that by a capital letter, but that is an end point, okay? It's not continuing on, it's the end point. Ray, that's part of a line that starts at an endpoint and extends forever in one direction. So you can see in the diagram, okay, there's ray RS, okay? Its endpoint and any other point on the ray. So sometimes there might be an extra point, but when you're labeling that, the biggest thing that you just have to remember is when you're labeling a ray, okay, there's only one arrow. You got to make sure that arrow is above the letter where the arrow is continuing from, okay? Because if you put RS, but the arrow was above the R, okay, that would be wrong. Okay, so you got to make sure you're labeling with that when you're putting the letters, okay, you're labeling above as the same as the diagram that you are given. All right, and the diagram has 2 pictures, okay, but those will still both be labeled RS with that arrow above the S. All right, and then there's the opposite rays that are below ray, and that has 2 rays that have a common endpoint and they form a line, okay? So even though that's a line that extends on from forever on both sides, okay, they're still rays with EF and EG, because E can be that endpoint for those rays, okay? So EF, EG, those arrows are above the E, or sorry, they're above the F and they're above the G, because that's where it's continuing on, okay? So those are going to be our opposite rays. All right, I'll give you like 30 more seconds to finish that, and then I'm going to move on. there a glare from where you're sitting from the window? Just let me know if I ever need to close that window. All right, I'm going to go ahead and move on. Now we're going to talk about a postulate, okay? This might not make sense at the beginning, but just know the word postulate, okay? You don't need to know that next word. You can just ignore this because we won't see it. But with a postulate, okay, that is a statement that is accepted as true without proof, okay? That might not make sense right now, but eventually, kind of when we go into that chapter 2, we're going to be talking about proofs a lot more. And when we're going to have to prove that something is true. So prove if two angles are congruent. Prove if two angles are supplementary, okay? But when we talk about postulates, a postulate does not need to be proven because it is already true. So we don't have to prove it, okay? So anytime you have a postulate, we don't have to prove anything. It is accepted as true, okay? And we'll talk about some postulates, so hopefully that can make a little bit more sense. But if you see the word postulate, okay, it's accepted as true. Yeah. No, if you want to, you can, but you really don't need to. Just know a postulate is accepted as true without proof. Okay. Feel free to write these next ones so you know what a postulate is, but it's just going to kind of seem repetitive on what you've written, but just know what this means, okay? So if this is like the postulate 111, okay, it says through any 2 points there's exactly one line, okay? We don't ever have to prove this because it's a postulate, okay? It's accepted as true, all right? Even with the next one, okay? Through any 3 non-collinear points, there's exactly one plane containing them. So if there's 3 points in a plane, okay? And if 2 points lie in a plane, then the line containing those points lies in the plane, okay? So we have the 3 non-collinear, okay? We said it's collinear if they're all 3 on a line, okay? But they would not be collinear in that instance. All right, but there's one plane containing them in the second example. And there's that third one as well, okay? Again, we never have to prove that these are true because they are postulates. All right, I'm going to go ahead and move to an example, okay? So if I have this example right here, okay, it's going to say, name a plane that contains 3 non-collinear points, okay? So why is it not collinear? Who can tell me why it's not collinear? Why are those 3 points not collinear? Yeah, Adam. Yeah, the F's not in line, so what would make them collinear? What is it? How many points does it have to have in the line? Yeah, it's got to have 3, so that's why they're non-collinear, okay? They're all in a plane, so it's still a plane because there's 3 points, but they are not collinear, okay? Don't worry about writing this, okay? Just know what the word, we're going to talk about intersect here and there. So just know that an intersection is the set of all points that 2 or more figures have in common. So here is just some postulates about intersection of lines and planes. So just know if two lines intersect, then they intersect in exactly one point. If two planes intersect, then they intersect in exactly one line. Okay? Again, we do not have to prove these because they're accepted as true. All right. We'll do some examples in a moment. We'll just do all our examples from the two sections together, but that is the end of section 1. Okay, so now we're going to move into measuring and constructing segments. Okay, so if you want to go to a new page, you can, or you can just put a line. You can just put 1, 2. But this is going to be measuring and constructing segments. All right. We're actually going to be doing some math here, so you can have your calculator out if you want. But I want you to just do some warm-ups. The title's still on the top there, okay? But go ahead and do those problems. Don't worry about number 6. Just do 1 through 5, okay? And let's make sure that you guys know this Algebra 1. So just go ahead and do 1 through 5, and then I'll call on a couple of you to answer those questions. I don't have one, but I can give you a pencil. Okay. Sorry, I need to get one. I don't know what happened to my other one. All right, just do 1 through 5. All right, I'll give you like 30 seconds to finish that up. And some of you are finishing up, some of you are done. And then we'll go over those 5, okay? Because when we're constructing these segments, we're gonna have similar questions that are they're gonna look like this. We're actually gonna do some algebra today. All right, Rocco, do you get number 1? Get number 1 on the board. Or your partner, can you help him out, Will? Yeah. So when you have 7 minus a negative number, okay, when you have minus a negative number, you got to make sure if you have that you're going to add them, okay? So you would add, and that would be just 10. So it would end up being 7 plus 3. Because if there's 2 negatives, you'll end up making them pluses, and they're going to add together, okay? So is that going to be similar on number 2? Yeah, what'd you get? 12. Perfect. All right. Then number 3, all right, what are these like brackets telling us? Yeah. Yeah, the absolute value. So what did you get for that one? 8. Perfect. Because when you do absolute value, what happens? Yeah, it makes the negatives positive. Perfect. So that ends up being 7 plus 1. All right. Who can tell me what they got for number 4? Yeah, Rebecca. X equals 2. Do we all get that? Perfect. And then what about 5? Maddie? X equals 5. Okay, perfect. Okay. We're going to be using some of this like math today and for our section 2. Okay. And number 6, when we talk about number 6, does anyone have an idea of what that would be? Yeah? It would be an infinite number. There's an infinite number in between 1/2 and 3/4. Okay. The distance is 0.25, but it's an infinite number because it asks how many numbers are there between them. Okay. So just know, here's just a little bit, okay, you don't really need to write this down, okay? What we're going to be talking about is we're going to be talking about the distance between 2 points. Okay, it says it's the absolute value of the difference of the coordinates. All right, don't really worry about that. Just know we're talking about distance, and we're finding that distance between 2 points, okay? This says the distance, the distance between A and B is also called the length, okay? All right. So when you're doing that, okay, you can do it in a way of absolute value. But if we looked at this one right here, okay, if you're just finding the length of BC, what is that going to be? Yeah, 2, okay? What about AC? Yeah, 5, okay? Yeah, those are pretty simple, okay? Those are going to be the numeric versions, okay? And what this is telling us with the absolute value is the way you could just do it is 1 minus 3, it's the absolute value of that, okay? Or AC, you can do -2 minus 3. I think that's complicating it a little bit because you can kind of just see the distance. And I think you guys could pretty much just do 3 minus 1 instead, or even just 3 minus -2, okay? Nope, you don't have to worry about it. Just know what we're talking about there, okay? Okay, when we talk about congruent segments, okay, this is important to know what tick marks are, okay? So if we have 2 segments that are the same value and that they are congruent, okay, these tick marks are going to tell us that those 2, in this example, those 2 line segments are congruent to each other. So they're going to have the same exact value, okay? So in some examples, it's not going to tell you they're congruent. But if we see these tick marks, we know that they're what? Yeah, we know that they're congruent. We know that they're the same value. So if QP is, let's say it has the value of 5, what's RS? Yeah, it's 5, okay? You just got to make sure you know what these tick marks are, okay? Because if you just forget, then everything's going to get complicated because you're going to see these tick marks throughout the whole year. So you just got to make sure you know that that means they are congruent to each other, okay? Say that again? Most of the time they're going to be red, but like let's say I write an example on the board, okay? I'm not just going to change out my marker just to take up extra time, but if you see those lines, then they're congruent. And then eventually we're going to get into, you'll see even more tick marks than that, and we'll see tick marks with angles, okay? Now, we got to just make sure, when we're talking about congruent and equal, okay, those are going to look a little different. So when we say that line segment PQ is congruent to RS, it's got to look like this. And I don't know why there's not a line above this PQ, but you got to make sure you have that line above the PQ and RS. And a congruent is like it's an equal sign, and then it's just got a little squiggly above it, okay? I don't really know what to call that, but I'm just going to call it squiggly, okay? You got it's like an equal sign with a little squiggly above it. That tells us that they are congruent, okay? When we talk about lines, line segments, and angles, okay, those are congruent, okay? But when we talk about values, those are equal. All right, and again, we'll talk about that later on, but just know that difference in what we're talking about there. We don't have to worry about that. Okay. All right, this is going to talk about another postulate, okay? So this is what our problems are going to kind of look like today, okay? So this one is talking about segment addition postulate. So it says, if B is between A and C, then AB plus BC equals AC, okay? And this is a postulate, meaning, so if it's postulate, what does that mean? Yeah, it's true, okay? We can accept that it's true, all right? So all 3 points are on that line. So again, we can say AB plus BC, that's going to equal AC, okay? I think that kind of makes some common sense, okay? But when you get to problems like this, you just got to remember, okay, those 2 line segments of AB and BC, okay, those are going to equal AC. They're going to add up to equal AC. Pretty much just know that basic part, okay? I'm going to move on. Just ignore the -6s. I don't know why they're there right here. But if we have that G is between F and H, FG equals 6 and FH equals 11, okay, we need to find GH. So go ahead and try that on your own, and then we'll talk about it, okay? So find GH and use that, what we just talked about in that previous slide, to help you, okay? And if you need to draw out that line segment, draw out the line segment of FH, okay, and know that G is in between it. All right, because drawing these out might end up helping you later on, okay, because when you solve these, they're not going to have the line segment every time. All right, it's pretty much just going to be words, just like this with our examples. Yeah. No, it's just saying segment FG. I don't know why it doesn't have like a, well, it's not usually going to have like a line above, okay? But you just need to know this is talking about FG, okay? It's not multiplying, so it's just naming the segment. All right. So when we have this, yeah. When we have this, so if FH is our, I don't know why I'm marking all the way over here when I have markers here. If we have, and it tells us that G is between FH, we can go ahead and draw out a line segment, FH. All right, and G is in between, so I'm just going to put it in the middle, okay? Maybe that picture doesn't, FG and GH, it looks congruent there, but we don't have the tick marks, okay? So maybe FG might be a value of 2, GH might be a value of 17, okay? It doesn't matter, we're just drawing it out so we can look at what that's going to look like, okay? It tells us, okay, FG is 6, okay? So I'm just going to put 6 right there, and it's telling us FH, the whole line, okay, is 11, all right? And we need to find GH. So I'm going to label that as X. Maybe it doesn't look like the best X, but there we go. All right, so that's how I would draw it out. All right, and then I can see and I can visualize where those numbers are and how to find GH, okay? So if I'm finding GH, what we said earlier with that postulate is And we said that FG, oh my, FG plus GH equals FH. Okay? So this just has different letters. Then that AB plus BC equals AC. Okay, and let's just plug in our numbers that we have. So we have FG is 6. All right, plus, we're finding GH, so I'm going to put that as X. And it's going to equal FH. And what's the value of FH? 11. Okay? Then we just need to do one step in order to solve for X. So what do we have to do here to solve for X? Yeah, subtract 6 over on both sides. So we move down X. Okay, and what's 11 minus 6? Yeah, 5. Okay, and then there is our value right there. So I believe this slide is going to kind of describe that in a way right there. Okay, does that make sense? Do you have any questions about that? Okay, you can see the way that it has it on the slides. All right, so for GH, you should have got 5. All right, now let's look at this one. All right, ignore this again. I don't know why this is showing up down here. This says M is between N and O, but this time we have X's in it. Okay, we need to find NO. All right, well, if we look at that image, okay, that image tells us NM is 17. All right, MO is 3x minus 5. All right, and then the whole length of NO is 5x plus 2. All right, who can tell me how we can set this up in order to solve for x? Yeah. Yeah, so we're going to say NM, okay, that's 17, all right, plus MO, this is going to be 3x minus 5, and that's going to equal the whole length of NO, so 5x plus 2. And then we would solve from there. So I'm just going to write it up here on what we did, and I'll get out of the way in a second. Okay? And then that's going to be how we can solve for x. All right? And I'll just start that in a second. Try to do that on your own. And then I'll walk through it step by step. All right. The first thing that I want to do is I want to get rid of common numbers or common variables on the same side. Okay? So on this left side, okay, we have 17 plus 3x minus 5. What can we combine before we do anything? Yeah. Yeah. Since 17 and 5 are on the same side, let's just cover the 3x plus 3x. So it says 17 minus 5. We'll go ahead and do that. So what's 17 minus 5? Yeah, 12 plus 3x equals 5x plus 2. Okay, go ahead and close your computer. You don't need it out. All right, then what do we do? Yeah, we can subtract the 2 from the right side to the left side to 12. All right, when I subtract the 2, what else can I do? Yeah. Yeah, we'll subtract the 3x on both sides as well. Okay, so what does that give us on the left side? 12 minus 2? 10. And what's 5x minus 3x? Yeah, 2x. Then what's our final step? Yeah. Yeah. And what do we get for x? There you go. I was just about to ask that. So we found x equals 5. This is where people hurt themselves on tests or quizzes. They get x equals 5 and circle it. All right? Is that what the question asks us? No, it asks us to find NO. So what do we have to do with x equals 5? Yeah. Yeah, we need to plug it into NO. So our NO is 5x plus 2. So we're going to go ahead and put 5. N for x plus 2. So what's 5 times 5? Plus 2? 27, yes. Okay. All right, and then here's the step-by-step if you need to see it here. All right, it might look a little different than what we did on the board. All right, but you should get 5 equals x, okay? All right, then that next slide is going to show us we need to plug it in, substitute the x to get 27. All right, do we have any questions on this? Okay. Go ahead and do this one for me. All right. Whoa, it didn't move. Here we go. E is between D and F. Find DF. So go ahead and do that one. I'm going to get out of the way in a second. All right, make sure you read the instructions on what you're finding. Oh, you went through that quick. And it is Madison, right? Madison? Okay. I'm trying my best with names, but I feel like a lot of the freshman boys look alike. All right, it has the image for us, but who can tell me how they set up the equation in order to solve for x? Yeah. Okay, that's fine. You set it up as 3x minus 1 plus 13 equals 6x, okay? All right, you just went ahead and added that, or did the negative 1 plus 13, and that's how you got 3x plus 12 equals 6x, okay? And then when you solve that, what do you get for x? Perfect. Okay, you should have got x equals 4. Are we done? No, why not? Yeah, we got to plug it in. And what do we plug it into? Yeah, for which one? 3x minus 1? Yeah, just the 6x. So what's 6 times 4? 24. Perfect. All right. Now I'm going to move to this. All right, let's go ahead and look at the board. And we're going to do some examples together, okay? We don't have to pay attention to the numbers, so we might go a little bit out of order, but just know that. All right, we'll go a little quick on these. Who can tell me one way we can name number 1? Yeah. Sorry, what was that? It is a line segment, but how can we name the figure below in 2 different ways? Well, what letters does it say on there? Yeah, so if I put SX, then what do I have to do with that, though? Who can tell me? Yeah. Yeah, you just got to put a line over it. All right, what's the other way that we can name this? Yeah, AJ? Yeah, XS, and what do we put above? Yeah, just a line. Is there any arrows? No. Okay, I'm going to change the color so it doesn't look like the images. Okay, let's go to number 2. All right, we can name the figure in 2 different ways. So what kind of figure is this? It is what? Yeah, it's a ray. So what's one way we can name this? We can do, yeah, there's a couple ways. Okay, We can do, I think you said XD. Oh my, that's a great D. But and then what do we have to put above? What do we have to put above the XD? Yeah, Will? So the arrow above the D? Okay, perfect. All right. Then you can do XT. All right. I think Delta Math, these are the two ways it wants you to put it in. All right. Because the arrow is continuing off from that T. Okay. So XT can be another way. All right. When we have number 5, what's a way that we can name this plane in the diagram? Yeah. Number 5. We're going to the right. Yeah, Will? Okay. There's a lot of different ways we can name this. We're naming the plane, so we're naming the highlighted region. Can you see the highlighted region? So how can we name a plane? Who can tell me how can we name a plane? What do we have to do? Yeah, Maddie? We need to get points inside the plane, but how many points do we need? I think we just need 3. So what's 3 points in the plane, Maddie? Yeah, we can do Q, M, N. All right. We're just going to stop there because there's a lot of different ways we can name this. Yeah. Yep. You should, yep. All right. I don't think like P would be an example because P is behind it. Okay. But you can do anything with Q, R, M, and N. All right. How? There we go. All right, let's look at 3, 4, and 6. All right. What's number 3? Yeah, Will. Yeah, it's a line. What's one way we can name it? XL, and what it has to be above it? Yeah, with 2 arrows. Okay. Another way you can just do is LX. All right. There's just 2 different ways. Make it easy. All right, so you don't even need to involve T at all. All right, number 4. What's number 4? Yeah. Hooray, yeah. So what's one way? Perfect. And then your other one, like we said above. Oh my gosh. Sorry, it is the first day. These arrows are terrible. All right, another way, you can just do that. Oh my, this is supposed to be, ignore this. HV. All right, what about number 6? What's one way you can name this plane? Yeah, Adam? Perfect. Yeah, it's an H. You're just going to have to learn my handwriting. Maybe isn't the best. It's a math teacher handwriting. Okay. Do we have any questions about those? Um, Give me 1 second. I'm reminding myself how to use this. All right, let's look at number 7. Okay, it says look at the diagram and evaluate which of the following statements below is true. So go ahead and look at that. Does that help at all? So number 7. We're saying which of the following is true. All right, everyone just say the answer. Yeah, A. Perfect. Okay, that's the only one that's true. All right. What about number 8? Which of the following statements below is false? Say it together. Yeah, C. All right. I know it has midpoint in it, and we'll talk. You'll have a video about midpoints on Friday. Okay, so you'll know more about midpoints then. But just know, can anyone you think you can describe what midpoint is? Yeah, yeah. So midpoint is just the direct middle. Okay. 9. If we look at 9, all right. Which one of the following is false? Which one is this going to be? Yeah, Chainley. Hey, perfect. Okay. E is not the midpoint there. All right. Sorry, this tablet does not want to work for my fingers. Go ahead and do 10, 11, and if you could see 12, do 12. Ten, 11, and 12. All right, who can tell me what they got for 10? Yeah. IJ 6. Do we all get 6? Okay, what about 11? Someone else. You got him? 3. Do we all get 3? Okay, who can tell me what they got for 12? Rocco? G equals 7? Is that what we got? All right. We're going to skip 13. Oh, yeah. I have to go to the new page. All right. Let's see if you can do 14 on your own. Go ahead and try 14. All right, Jordan, what'd you get? 15. Perfect. Okay. So you can see I kind of walked it step by step right there. All right. Do 17. Mm-hmm. No, because you're adding them. You're not multiplying. Well, even, yeah. So it's x plus 1. So it's just 2x. Well, I'll give you like 20 seconds to finish that up. What happened? You're good. Wait. Your 5x minus 2 should equal these two added together. Because it should look something like this. All right. Here you go if you want to check that. What do we get for RS? Say it out loud. Yeah, 10. Okay. Any questions about today? All right. I know it might have seemed a lot. Okay. But you just got to get back into the hang of things. All right. I'm going to give you the remainder of time to work on Delta Math. Okay. So you can get your computer out and work on homework for the remainder of class. Yep. All right. Let's see if this recording works.